In this tried exercise, we are asked to use the rational zero theorem to find the rational zeros of f of x equals x cubed minus 5x squared plus 2x plus 1. And that should come with a disclaimer, or should say after that, if any exist, because they might not. So what we're looking at is, this is what some people call, the rational zero theorem. Some people call it the P's and Q's, because what we're ultimately looking at are plus or minus P over Q, where P is a factor of the constant, and Q is a factor of the leading coefficient. So what that means is that if there are any rational zeros, if we plug in x and it yields a 0, and it's a rational number, it's going to be one of these values, plus or minus P over Q, plus or minus a factor of the constant over a factor of the leading coefficient. So in this case, our constant is 1, so we're looking at plus or minus factors of 1 over, well, our leading coefficient is the same thing, 1, which makes this a lot simpler. Factors of 1. So what that means is that, P could equal plus or minus 1, because those are the only factors. 1 is the only factor of 1, and Q equals plus or minus 1. So what that tells us is that P over Q equals plus or minus 1 over 1, which simply just equals plus or minus 1. So now we need to check are -1 or x equals -1 or x equals 1, are those factors? So let's look at x equals -1 first. X equals -1. When x equals -1, we have f of -1 equals -1 cubed, x cubed, minus 5 times -1 squared. We're just plugging in x we're just plugging in -1 for x into our function. 5 times -1 squared plus 2 times -1 plus 1, which that equals -1 cubed is -1, -1 squared is 1, 5 times 1 is 5, so this is going to be minus 5. 2 times -1 is -2, so this is going to be minus 2, and then that's plus 1. Well, that equals -7. So that's not one of the zeros of the function. And when x equals 1, we have f of 1 equals 1 cubed minus 5 times 1 squared plus 2 times 1 plus 1, which equals 1 cubed is 1 minus 5 times 1 squared. 1 squared is 1 times 5 is 5, so this is just minus 5 still. Plus 2 times 1. 2 times 1 is 2, so this is just plus 2. And then we still have plus 1. So 1 minus 5 is -4, plus 2 is -2, plus 1 equals -1. So our P's over Q's, these are the only possible rational roots. These are the only factors of the constant over the factors of the leading coefficient, because the only factors of both are 1. So our possible rational zeros are -1 or 1. Those are the only possible rational zeros according to the rational zero theorem. So what this means is that there are no rational zeros. So any zeros for the function f of x equals x cubed minus 5x squared plus 2x plus 1 are going to be irrational or part of the complex number system. So f of x equals x cubed minus 5x squared plus 2x over 1. To find the possible rational zeros, we put plus or minus the factors of the constant over the factors of the leading coefficient. With each one of those, we substitute then into the function at those possible rational zeros and see if any of them equal 0 when we substitute into the function. If they don't, then that means that any zeros that exist, which in this case, since it's a third degree polynomial, there would be 3 zeros. Those 3 zeros are either irrational or they are complex. And we could see if they were in the real number system by simply graphing the function and seeing if it crosses the x-axis. If it doesn't cross the x-axis, then the zeros are complex.